For blood test number 7 in 2025, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 15 years younger than the chronological. So what might be contributing to these data? In the last video, we did a deep dive into supplements, and if you missed it, it'll be in the right corner. But in today's video, let's do a deep dive into diet composition, more specifically the diet composition that corresponds to blood test number 7 in 2025, with the full list of all 54 foods shown here. This is average daily dietary intake from September 16th through October 26th of 2025, and that's a 41-day period. So why that 41-day period? Well, it started immediately after test number 6, which was on September 16th, and it lasted until the day before test number 7, which was on October 27th, thereby leading to that 41-day period in between blood tests, and then this is the average of all dietary intake in between for those 41 days. Now, for those who don't know, I've been weighing my food since 2015 every day with a food scale. More than 99% of all food has been weighed over that 10-year period with the food scale. I then log that data into a diet tracking app, Cronometer. I then pull the Cronometer data into a spreadsheet, and then I'm able to look at average dietary intake over that 41-day period and line it up with the blood test. So now every blood test has a corresponding average dietary intake, and I can look at correlations, but that story is coming later in the video. So this list is ranked from top to bottom. 54 different foods were consumed in grams, with 2 exceptions. Green tea, which is in ounces, and if you want to use what I use, which is organic loose leaf green tea from Japan, there's a discount link in the video's description. And then cookies, which is in calories. And I have to always say at this point in the video, that's not 7 calories of cookies every day for 41 days. That's 1 day of cookies and 40 days of no cookies. All right, so at this point in the video, I always ask, did I do any experiments that were specific to this test? And the answer is yes, as I'm always trying to improve biomarker weak spots without messing up the rest of the biomarkers. Now, for this test, there were 3 specific experiments. In the first, I increased omega-3 intake to test the correlation with DHEA sulfate. So for those who don't know, why is DHEA sulfate important? It's important because DHEA sulfate impacts many age-related phenotypes, and that's what we'll see here. So after DHEA is produced by the adrenal gland and then sulfated, it impacts these age-related phenotypes, including osteoporosis, obesity, diabetes, cancer, atherosclerosis. It's immunomodulatory, which means that it's pro-immune and anti-inflammatory, and it's also neuromodulatory, which means it offers neuroprotection, and it positively impacts neuroplasticity, which then raises the question of what's optimal for DHEA sulfate. So that's what we'll start to see here as DHEA sulfate declines during aging. On the y-axis, we've got DHEA sulfate, plasma or blood levels of DHEA sulfate plotted against age on the x. And then we can see that in youth around 20 years old, median DHEA sulfate levels, and I should mention these data are in men, are 300 micrograms per deciliter, and that's around 8 to 9 micromolar. And then we can see that there's a precipitous age-related decline for DHEA sulfate. And note that these data are similar in women too. So relatively high in youth and then an age-related decline, although how high it peaks in women in youth is lower relative to men. So to address the question of what's optimal for DHEA sulfate, my reading of the literature is 300 micrograms per deciliter, as that's the median value found in youth. That's only part of the story. The other part of that story is its association with all-cause mortality risk. There too, relatively higher is better. The third part of that story isn't just getting one data point into the quote-unquote optimal range, it's avoiding this age-related decline. So even if your data isn't 300 micrograms per deciliter, resisting age-related change, say it's 200 or 150, trying to resist age-related change for as long as possible is also how I see optimizing this biomarker and many other biomarkers. And in terms of optimizing biomarkers, if you've ever wondered what's optimal, I have a new Patreon tier dedicated specifically to that. It currently includes these 35 biomarkers shown here, more than 2 hours of video content, 52 published references, and note that these data aren't the reference ranges. This is my interpretation of the published literature for what may be optimal based on how each of these biomarkers changes during aging and or associations with all-cause mortality risk. So if you're interested in that, check it out. All right, back to our story, where DHEA sulfate is a weak spot that I'm trying to improve, which is what we'll see here. This is DHEA sulfate plotted against age, chronological age, from 2022 to 2025, and I have 25 blood tests over that period, with DHEA sulfate plotted on the y-axis against chronological age on the x. Now, for the first 19 tests, the data was relatively stable, with an average DHEA sulfate of 126 micrograms per deciliter. But then take a look at the most recent 5 tests, as there's been a precipitous decline. In fact, my lowest ever DHEA sulfate over this 4-year period and these 25 tests. So these data are definitely moving in the wrong direction, especially within the context of what's optimal. As I mentioned, 300 micrograms per deciliter is the target, and I'm nowhere near that at 126 micrograms per deciliter. Additionally, in terms of resisting age-related change, more recently, I'm not doing great. Although DHEA sulfate was relatively stable for those 19 tests, as I mentioned, whatever's going on for the past 5 tests, I've got to try to reverse that, and quickly. Which then raises the question of what can I do to reverse these data? So following every blood test, I calculate correlations, as I mentioned earlier. So after test number 6, I calculated correlations, and then I tried to follow those correlations with the goal of moving DHEA sulfate and other biomarkers in the quote-unquote right direction. Now note that we are currently on test number 7 in this video, so I want to show what my thought process was after test number 6 in following the correlations to try to move the needle for test number 7. Now, one of those correlations is shown here. This is DHEA sulfate plotted against average daily omega-3 intake. And as I mentioned, this is just one of the correlations. The full correlation list for biomarkers versus diet are on the correlations tier on Patreon. So if you're interested in that, check it out. So here we can see that there was a significant positive correlation for omega-3 intake, and this is not from supplements, this is from whole foods, with DHEA sulfate, with a correlation coefficient of 0.41 and the p-value right at the threshold of statistical significance, 0.05. If correlation equals causation, and I'm not saying that that's the case, but the only way to know is to do the experiment and find out. If I eat relatively high omega-3 towards the high end of my range, again, if correlation equals causation, I should expect to see relatively higher DHEA sulfate in my data. So that's what I did. But then it raises a question of omega-3 from what? What am I getting omega-3 from? What are my primary sources? Well, they include walnuts, sardines, and flaxseed. Neither of those, in looking at the p-value, had a p-value less than 0.05. Which then raises the question of what do? I have a significant correlation for omega-3 with DHEA sulfate, but I don't have any significant correlations for the foods that provide the majority of my omega-3. So with that in mind, I decided to increase each of them. As we'll see in a minute, I'll show the exact amounts that I increased them to try to move the DHEA sulfate needle. But note that it didn't work. Again, this was a part of the story for my worst ever DHEA sulfate over these 25 tests. So in terms of what did I change in terms of those 3 foods, in terms of the amounts, I increased sardine intake from 92 to about 143 grams per day, so the majority of the omega-3 came from sardines, with relatively smaller increases for flaxseed. You can see 21 to 23 grams per day, and walnuts increased from 3 to about 8 grams per day. Again, it didn't work though, so I've got to come up with a different recipe for improving DHEA sulfate for test number 8. With that in mind, what's the plan for test number 8? Following test number 7, I then recalculated correlations. And again, if you want to see the full list, that's on Patreon in the correlations tier. So this is the top of the correlation list for DHEA sulfate versus foods following test number 7. With the correlation coefficient in the middle, the p-value, you can see each of these foods is significant at a p-value threshold of less than 0.05, and then the n is 25 tests over this about 4-year period. And what we can see is positive and negative correlations. The positive correlations suggest that when intake of the food is relatively high, that's significantly correlated with higher levels of DHEA sulfate. Again, correlation, not causation. I am not at all implying causation. The only way to know about causation is to do the experiment. And then there are also negative correlations on this list, which suggests that relatively higher intake of the food is significantly correlated with lower levels of DHEA sulfate, which would be moving in the wrong direction. So atop the list, for whatever reason, is added salt intake with a positive correlation of 0.78. But then digging deeper, there are other positive correlations, including dates, vanilla bean, beets, and coconut butter. If I follow all of those correlations, will DHEA sulfate be at the relatively higher end of my range? That's a part of the plan, while also trying to minimize inverse or negative correlations as shown in red. And surprisingly, olives are inversely correlated with DHEA sulfate. Whether that's related to the well-known effect of olive oil being able to reduce LDL, and LDL, which is cholesterol, is involved in DHEA synthesis, I'm not yet sure, but the idea that relatively high olive or olive oil intakes may be best for everyone, in my case, maybe not, at least based on my correlation for olives with DHEA sulfate. Besides olives, we can see nutmeg, inversely correlated. That data would be moving in the wrong direction too. If you saw the video on nutmeg and one of its metabolites increasing lifespan in animal models, I'd like to keep it in the approach so that it would potentially lead to lower DHEA sulfate would be bad news in my data. Avocado, celery, corn, kimchi, and lemon are also inversely correlated with DHEA sulfate, potentially bad news. So in terms of the plan for test number 8, the goal is to follow as many of these correlations as possible, keeping the positive correlations relatively high intake and reducing or cutting out the inverse correlations, foods that have inverse correlations. So with that in mind, with going into the specific numbers, I'll cover that for the test number 8 breakdown after test number 8, probably sometime in January. Test number 8 will be at the end of December though. So am I following those correlations? So I've added salt back into the diet. I've cut olive intake by about half. So I was getting salt intake from olives, leading to a reduction in added salt intake. So now I've reversed that, where I've added salt back into the approach and cut olive intake by about half. I've removed nutmeg, removed avocado, and I've also cut celery by about a third. In terms of the other correlations, it's about a mixed bag. I'm following some, but not following the others. So the top 5 correlations, so I am following all of them, as I don't know if any of them will impact DHEA sulfate. Now, if these are quote-unquote real correlations, the correlation will stay relatively strong or get a bit stronger, meaning it'll move closer to 1 or -1. All right, so back to the any experiments for this test. So MCV has been moving in the wrong direction for a bunch of tests going back over the past few years, and I covered that story in an earlier video. If you missed it, it'll be in the right corner. So for those who don't know, what is the MCV? Well, it's the mean corpuscular volume, so it's the average volume of red blood cells, which can be visually illustrated here. So here we can see a red blood cell that has a relatively small volume, that's a low MCV. A red blood cell that has a bigger volume, so that's a medium, intermediate MCV, and then big red blood cells or big volume, that's a high MCV. MCV increases during aging. Low MCV is more likely to be found in youth. So that's one part of the approach for what's optimal for MCV, having relatively small red blood cells. So following test number 6, Brazil nuts were positively correlated with a higher MCV, which is data potentially moving it in the wrong direction. And again, it's important for me to highlight this. This is a correlation, it's not causation. The only way I can test causation is to do the experiment by testing the correlation. So that's what I did. I reduced Brazil nut intake from 12 grams to about 5 grams per day. And we can see the correlation on the left. Following test number 6, that correlation coefficient was 0.72 and the p-value was far below 0.05. But note that following that correlation by cutting Brazil nut intake, it didn't work. This is a part of the story for my highest ever MCV, over 60 tests going back to 2015 at about 96 femtoliters. So then I recalculate the correlations. And as I mentioned, if a correlation, following a correlation doesn't work, it weakens. And that's exactly what we can see after calculating the correlation after test number 7, as that correlation coefficient moved from 0.72 to now 0.64. So it weakened by a bit, and you can see that the p-value, it moved a bit closer to 0.05, albeit still statistically significant, from 3 times 10 to the -8 to 2 times 10 to the -6. So it's still a significant correlation, but based on this one test, it seems that Brazil nut intake is not a part of the lowering MCV story. Which then raises the question of what am I going to do for test number 8 to bring MCV closer to what I consider as optimal, around 90 femtoliters. I'm currently testing correlations for lycopene and cacao for MCV for the next test. For whatever reason in my data, relatively higher or highest lycopene intakes are positively correlated with MCV. That would be data moving in the wrong direction. And cacao is inversely correlated with MCV, so relatively higher intakes are significantly correlated with lower MCV. So I've cut lycopene intake, specifically tomatoes, not cut them out. They're still in the diet, albeit at a lower amount. I'm aiming for about 125 grams of tomatoes per day, not about 200, which is where it's been for the past few tests. And I've added cacao beans back into the approach, 10 grams per day. Now, I haven't gone higher because SAT-fat in my data is significantly correlated with higher levels of cystatin C and B2M, which are important predictors of grim age. So I'm trying to keep SAT-fat relatively low, thereby keeping cacao beans relatively low. That's why I haven't gone relatively high intakes for cacao beans yet. So the third experiment involved increasing fat intake to test the correlation with lipoprotein A, and I'll have more on that in the macronutrient breakdown of this video. But for now, let's take a look at cheat meals, because I know that there are some people in this space that absolutely never cheat on their diet, and unfortunately or fortunately, however you want to look at it, I'm not one of them. And that's because if I try to go completely cold turkey and have no cheat meals ever, that historically has increased the probability of eventually breaking and having a binge and just going crazy with calories and junk for a few days, which throws everything off track, and it can ruin literally months of hard work in terms of calorie restriction and exercise training and all of that. And even mindset, mental health. I'm not trying to do that. So what I found what works best for me is immediately after blood testing, it's like I won the Super Bowl. I go out and quote unquote celebrate with a cheat meal. Now on those days, I try to stick to the calorie targets that are on that day. So if it's a workout day, on a blood test day, around 2,500 calories at most. Generally is harder to do when there's some cheat meals, because cheat meals, although initially satiating and delicious, can lead to less satiety later in the day. So I try to include the cheat meal while also sticking to the calorie targets for that day without going a bit too high above that. Now note that the cheat meals aren't just limited to one day. What I found that works for me is on the day after, immediately after testing, the day after, and then up to about a third day. And after that, I'm pretty much satiated on cheat meals or junk, and then it's locked in completely for the rest of the diet. No cheats after that. So for this test, it was 3 days of cheats and then 38 days of completely clean back to the standard diet after that. In terms of what those cheat meals involved, it involved, well, it's basically a standard. Almost every blood test, immediately after blood testing, I had peanut butter. I just love peanut butter. It's great. Immediately after testing, I had peanut butter mixed with jelly, specifically that jelly there. And I also had some peanut butter mixed with Nutella, which was delicious. You know, it was so delicious, I decided to have it for the second cheat day too. On the third day, I mixed it up a bit, where I had those Chips Ahoy cookies. I blended them up, I ground them up into a fine powder, and then I mixed them with sugar, powdered sugar, and heavy cream to make a homemade ice cream, which there too, it was completely delicious. 3 days of junk, 38 days, no junk, back on the standard diet. In terms of the amount of junk calories that came from Nutella, 950, blackberry jelly was 438, and from the added powdered sugar, it was 160. Technically, I could add the whipped cream to the junk calories as it is an ultra-processed food. They do add additives to it. I'm not sure if I should do that. If people say in the comments that I should add heavy cream to the junk calories list, I'd be happy to do that in future videos. I'm not trying to skimp and make it look like the diet was more clean than it is. I'm happy to add it if people think that it's a junk food. In terms of junk calories, about 1,550. And when divided by all of the calories consumed during this period, it was 1.6 of all calories, so the diet was about 98% clean relative to how much junk was on these 3 days. All right, so this list is ranked in grams. What about ranking foods based on calories? And that's what we're gonna see here. This is the top 10 foods for average daily calorie intake that correspond to this 41-day period from test number 6 to test number 7. And note that this list is generated by Cronometer. If you wanna measure your own diet with Cronometer, there's a discount link in the video's description. So in terms of the top food that provided calories, it was sardines. So I'm not a vegan, I haven't been a vegan for about 9 years. Every day I've had fish since then, so it's a staple in the diet. In terms of the other foods that are in this top 10, I won't go through them all. 8 of the 10 foods that were in the top 10 list for test number 6 are also in this list for test number 7. In terms of what entered the top 10, avocados and almonds, and pistachios and Brazil nuts left the top 10. Still in the diet, but just not in the top 10. All right, next up is macronutrient composition, starting off with calorie intake, which average calorie intake for this test, 2302. And in terms of how that ranks relative to other tests over the past 6 months or so, my past 4 test average is about 2,300 calories, 2292 to be exact. And I've done that because I'm trying to stay weight stable. So body weight declines in the second half of life, and I'm trying to avoid, and granted, I don't think I'm in the second half of life. Maximum human lifespan is 122, I'm currently 52, so I don't think I'm in the second half of life. But when considering that body weight declines during aging in the second half of life, I'm trying to stay weight stable indefinitely, not lose an ounce of muscle or fat. Well, actually, I'd like to lose as much visceral fat as possible while optimizing as much muscle mass as possible within my current body weight of 140 pounds. Protein intake for this test average was about 126 grams per day, which was 22% of total calories. Next up is fat intake, which is what we can see here, an average of about 101 grams per day, and this is 39% of total calories. That 101 grams per day was an increase relative to the prior test of 84 grams per day and 33% of total calories. So where did that fat increase of 17 grams per day come from? Mostly monounsaturated fat. And if you remember earlier, I did that to test close to or significant correlations for total fat and monounsaturated fatty acids, MUFA, with lower lipoprotein A. Unfortunately, it didn't work though, as we'll see in a minute. The big question though is fat from what? Because although I have significant correlations for total fat and MUFA with lower lipoprotein A, where did I increase fat from? Avocado intake was inversely correlated with lipoprotein A after test number 6. So to test that correlation, I added avocado, more than doubling its intake from 41 to around 87 grams per day. But there too, it didn't work. So far I've struck out 0 for 3 on all of the experiments that I tried to move biomarkers. It didn't work. And I try to be as honest as possible with these things. I'm happy to celebrate successes, but I'm also going to show the failures and then try to learn from them so that I can improve. So lipoprotein A for test number 6 was 81 nanomolar. For test number 7, it was 80 nanomolar, despite following this correlation. Which then raises the question of what's the plan for lowering lipoprotein A, as that's a bit outside of the reference range. And lipoprotein A is 6 to 7 times more atherogenic than LDL. So I'd like to reduce lipoprotein A even lower if I can. Now, for those who are going to say it's genetic and it can't be moved or manipulated, in my data, I've had lipoprotein A values as high as 145 nanomolar, with an average over the past 10 years of about 90 nanomolar. So it is possible to stay closer to one's lower end of their reference range or of their range, but I'm trying to push it even lower if I can by following the correlations. So how will I try to do that for test number 8? Well, I have a significant inverse correlation for chickpeas with lipoprotein A. So as a heads up for the test number 8 diet composition video, which again probably won't happen until sometime in late January, or it won't be on YouTube until sometime in late January. That data will be on Patreon immediately after I get the blood test results, testing sometime later in December. I've doubled chickpea intake relative to where it is here to about 80-ish grams per day, relative to about 40 grams per day. So stay tuned for that data, whether it worked or not. All right, so back to the total fat story. So we can see that omega-3, I increased it by about 2 grams per day, again from the combination of sardines, walnuts, and flax seeds. Omega-6 was a bit higher too because of the increase in walnuts, and I kept sat fat relatively low to test correlations or to repeat test correlations for cystatin C and B2M, which stayed relatively low again for the second test in a row, which supports, for whatever reason, relatively low saturated fat in my diet being better for cystatin C and B2M. All right, next up is carb intake. And that's what we'll see here. So total carbs are 267 grams per day, which seems like a lot, but note that net carbs equals total carbs minus fiber. Average fiber intake for this test was 82 grams per day. And when subtracting that from total carbs, we get a net carbs of 185 grams per day. We'll multiply by 4 calories per gram. That yields around 32% of the diet coming from net carbs. Now note that fiber, a fraction of that, about 20%, is fermented by gut bacteria into short-chain fatty acids. In other words, gut bacteria make fat from fiber. And it's about 150 calories from soluble fiber coming from the total fat pool, because total fat is comprised of insoluble fiber, which is not fermented by gut bacteria, and soluble fiber, which is fermented by gut bacteria into these short-chain fatty acids, acetate, propionate, and butyrate. So that 150 calories coming from soluble fiber fermentation leads to about 6.5% SCFAs, which I can then add to get net macros for this test, which was about 46% fat, 32% net carbs, and 22% protein. Now, I should mention that this net macronutrient profile was not associated with my best biological age for any test so far over the first 7 tests in 2025. So one could argue that my fat intake is a bit too high, my protein intake may be a bit too high, and net carbs may be a bit too low. Now, also on this list is sugar intake, and I'm not tracking sugar intake because it's a diverse group of molecules, including glucose, lactose, galactose, maltose, fructose, etc. But what I am tracking is total fructose, with fructose and sucrose. Half of sucrose is fructose, so dividing that by 2 and adding it to fructose yields a total fructose amount. Having relatively higher fructose intakes is significantly correlated with more biomarkers moving in the wrong direction than right. And the diet is fruit and vegetable rich, which contain a lot of fructose, so I have to be careful with how much fructose that I consume. So for this test, total fructose was about 50 grams per day. And I should mention at this point, I have to say, that seems like a lot, but over the past 10 years of tracking diet, I've had fructose intakes that correspond to a blood test that are way higher, 122 grams per day. Also, this 50 grams per day of total fructose was lower test over test. For test number 6, it was 57 grams per day. So here too, and I say this a lot, progress, albeit not perfection. Now, in considering that lowering my fructose and overall fruit intake was a part of this story for a 15-year biological age reduction, that was not my best, far from my best, with data going in the wrong direction over the past 6 tests since the first test. One could argue that maybe I shouldn't cut fructose intake. So that too is a part of the plan for test number 8, and I've increased strawberries. We're going to see a lot of strawberries in my diet composition video for test number 8, so stay tuned for that data coming in a future video. All right, next up are micronutrients, and that's what we'll see here with the full list of vitamins. It may be hard to see, so I'd encourage going full screen if you haven't done that already. And without going through all of the vitamins on the list, for anyone starting on this journey, and I always have to say this, I think this is the most important, lowest hanging fruit, the goal should be to at least get RDA coverage for all vitamins and minerals. Now, what's optimal beyond that? It's looking at correlations between your diet and supplements with a standard panel of biomarkers, and then trying to course correct. It's the F around, find out, test over test over test, to try to find your own personalized recipe for optimizing biomarkers. So with that in mind, many micronutrients on this list, on the vitamin list, and as we'll see for the mineral list in a second, are much higher than the RDA, as I'm following their correlations with a standard panel of 25 to 30 biomarkers. I've highlighted the carotenoids as shown there in the green box. If you'll notice, for the carotenoids, they're pretty high. And there aren't RDAs established for the carotenoids, but I covered in an earlier video that carotenoids are consistently associated with a relatively younger biological age, so I think it's important to keep them relatively high. So if you missed that video, it'll be in the right corner. All right, so in terms of minerals, I just want to highlight one important factor, and that's sodium intake, which for this test was 2,700 milligrams per day. In an earlier video, I pitched the hypothesis that sodium can lower norepinephrine, which may be involved in hair graying, but also optimizing HRV and resting heart rate, but on the other hand, negatively impacting blood pressure. My blood pressure, since increasing sodium from about 1,700 milligrams to 2,700 milligrams per day, has been moving in the wrong direction. So as a heads up for the test number 8 diet composition video, I've since cut sodium intake by about 500 milligrams per day to reevaluate correlations to see how lowering sodium can impact all of the above, HRV, resting heart rate, and blood pressure. So I'm planning on an update video for that at some point in the future. All right, so whether it'll all work, we'll find out very soon. The next blood test is scheduled for sometime between December 15th and December 26th. I've actually got 3 blood tests scheduled during that period, and I do that because this is flu season. So worst case scenario, something happens and I have to reschedule. I've got backup tests for the 15th, the 22nd, and the 26th, so I haven't specifically nailed down when that blood test is going to be, but I'm intending on getting it done by the end of this month. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults and also post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, at-home metabolomics, oral microbiome composition, NED testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with SciFox Health, which includes GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including Data is my North Star, Figuring Stuff Out is my drug, and the ConquerAging or Diet Trying logo, which I've got on here. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.